This is select answers to SP52, number 12 and number 4 on the back side of your sheet. When graphing rational functions, it's best to find a horizontal asymptote and vertical asymptote, because then you have boundaries for where your rational expression will start to approach those asymptotes. Now, when we worked in class, our rules for horizontal asymptotes applied to P of x over Q of x. That's what we discussed in class. And this function is not written in that form. It's not a polynomial over a polynomial. It's got this -1 here, so that -1 is causing issues for us. But we can write it in that form. So to get that into P of x over Q of x, I need to write it as one rational function. So I need a common denominator. I want to combine these two so that I can get it as one function. So my common denominator is 3x minus 2. So I'm just going to go ahead right away and write 1 as 3x minus 2 over 3x minus 2. Again, that's equivalent. And now it's just a matter of simplifying. So I have 4 minus 3x plus 2 over 3x minus 2. So that'll simplify to negative 3x plus 6 over 3x minus 2. So now it's in the form where I can look at the horizontal asymptotes. So I look at the degrees. The degree in this function, its highest valued exponent is 1, and the same thing here. So I have the case where I've got the degree of P of x equal to the degree of Q of x. So what that means is that I take the leading coefficient over the leading coefficient. Leading coefficient in this case would be negative 3 over 3. So that would be negative 1. And I've got a horizontal asymptote. Remember, those lines actually start with y equals negative 1. So I can go ahead and draw my horizontal asymptote in. And there I've got my horizontal asymptote. To find my vertical asymptote, I just need the values that are undefined. So I just set 3x minus 2 equal to 0. So my line for my vertical asymptote is going to be x equals 2/3. Go ahead and draw that in. From there, you want to find points so that you can actually sketch your graph. Finding the x and y intercepts would be good, so plug in x equals 0, plug in y equals 0, and then just find a couple more points just so that you can get the appropriate shape of the graph. And after you've done that, all you need to do is draw in your graph, and you've got it. I generally pick points on either side of my intercepts so that I can see how fast it's going to approach the asymptotes. And last, we have to find the domain and range. Domain is all the possible set of x values. So when I look at my x-axis, I could plug in any x value going towards positive infinity, except for this 2/3, that will block me. Same thing here, I can plug in any x value for my negatives except for that 2/3. So when I do domain, I just write it like this: x such that x cannot equal 2/3. And that implies that any other real number will work. Then the range becomes the same idea. As I approach with my range, I can come from the negatives and get closer to my asymptote. Same idea. So I can hit any value except for my horizontal asymptote. In number 4, the first part that it asks you to find is the zeros. If you remember, zeros are the same as x-intercepts. And you also remember that at any x-intercept y equals 0. So to find the zeros, I'm going to plug in 0 for my y value. That's just f of x. And then I'm going to solve for the x values. So first step, multiply by x plus 1, multiply by x plus 1. That will give me 0 on this side, and I'm left here with a quadratic. Always check and see if a quadratic will factor first. This one will. I've got x plus 5 times x minus 1 will work. And then I want the values that would give me 0, so x equals -5 would give me 0. And x equal 1 would give me 0, so those are my two zeros. You can write it like this, or you can also write your zeros as points. Either answer is okay. To find the vertical asymptote, again, you just want the values that will make the denominator 0. That will give you your undefined values. So the only place where I'm going to have a vertical asymptote is at x equals -1. Then my horizontal asymptote, I look at the degree of p of x over the degree of q of x. Both of mine are polynomials, so it's written as a rational function, so I don't have to do anything with that. So my degree on top is 2x squared. My degree on the bottom is 1. So what that means is that I've got p of x, the degree greater than q of x. And this means that there's not going to be a horizontal asymptote. Again, when you plug in a really big number, like say if you were to plug in 2 million into x squared, that 2 million will take over and it will start to really blow up as your function. So it means that there's no line that it's actually approaching. There's not going to be an asymptote. And then after that, just find a few points along your, so graph your asymptote and then find a few points along there. I actually had to find 4 just to kind of see what shape my graph was going to take on. You're always good if you plug in 0 for x, and if you plug in 0 for y, then you'll get your intercepts. You can use a table on your graphing calculator to find that. You could just plug in points. A few different ways of actually getting the rest of the graph. Again, your graphing calculator won't actually show you asymptotes, and it won't show you holes, so you want to make sure that you understand the algebra needed to find horizontal asymptotes and vertical asymptotes.